Horizontal asymptote for rational function. So we are considering the three cases of horizontal asymptotes for a rational function. As you know, rational function is of the form of p over q, right? So we can write this as px over qx, where both p and q are polynomials. Now, there are three particular cases. One is when degree of numerator is higher than the denominator. The second is when both degrees are same, and the third could be that the degree of denominator is higher than that of the numerator. Here we have a case where denominator degree is higher than the numerator, right? So we'll consider in such cases what happens to the horizontal asymptote for a rational function. Now, this is a general solution which we can actually come up with. We are trying to do it with a specific question, of course, but the degree, when we say higher, in this case it is by 1, even if it is higher by 3 or 4, the result will be same. Okay. Now, what is a horizontal asymptote? When we are trying to work out horizontal asymptote, we are trying to figure out what happens to the function as x approaches plus infinity or as x approaches minus infinity. If the function f of x approaches a fixed value, let us say L, then we say that horizontal asymptote exists, and the equation of horizontal asymptote is, we can write horizontal asymptote is y equals to L, the value which the function approaches. Same is the case when we consider when x approaches minus infinity. If that function approaches a value, fixed value, let us say L, these two L's could be different, right? In that case, we have an horizontal asymptote, and the equation for horizontal asymptote will be y equals to L, right? So let's figure out for this function what happens when we try to find the limit of the function. That means we're trying to find limit of this function as x approaches plus and minus infinity. Now I'll do plus infinity, and the process for minus infinity is exactly same, which you can repeat, right? So let's find, so limit of this function when x approaches plus or minus infinity can be written as limit of the function, which is 2x plus 1 over 2x squared minus 3x plus 2. Now, what we will do here is we'll factor out x from both numerator and denominator, cancel them, and then see what we get. So we get limit as x approaches infinity. Let's factor x from the numerator. We get 2 plus 1 over x, correct? And in the denominator, if I factor x, I get 2x minus 3 plus 2 over x. That's what I get. Now, as you can see, x and x can cancel out. So you're left with 2 plus 1 over x divided by 2x minus 3 plus 2 over x. Now, what happens to 1 over x when x approaches infinity? Let's see. If it is 1 over x, and if at the limit of this as x approaches infinity, so it will be 1 over a very large number. So this will approach 0. Similarly, 2 over x when x approaches infinity will also approach 0 as x approaches infinity, correct? Now it doesn't really matter whether x approaches plus infinity or minus infinity. In both the cases, this factor is going to approach 0. You see, this term will be 0. Even if x approaches minus infinity, this will approach 0, right? In both the cases, correct? So what we're trying to say, if denominator is very, very large, and if you divide by a very, very large number, you're bound to approach a very small number, which is approaching 0. That is what we're trying to say. So we can write this limit x approaches this as equals to limit x approaches infinity, and these terms will be 0 for us, right? So we get what? We get 2 over 2x minus 3. Since these two terms where we have x in the denominator will approach 0, so we could write like this. Now, if x approaches large number, what happens to the denominator in this case? This is 2x minus 3. If x is very large, this whole denominator will be very large, right? And therefore, this will also approach to 0. Do you see that? So 0. So the function approaches 0. 0 is a defined number, L. Do you see that? So as x approaches infinity, we see that the function approaches 0. And therefore, we do have a horizontal asymptote here. And the horizontal asymptote is y equals to 0. So for all these cases where degree of denominator is higher than that of the numerator, we have same horizontal asymptote, and the horizontal asymptote is y equals to 0 in all the cases, correct? So remember that if the degree of denominator is higher, horizontal asymptote exists, and it is at y equals to 0. Now the only difference could be whether you are approaching y equals to 0, that is the x-axis, from minus side or plus side. So whenever you're given a function, you have to test that out. So let's figure that out here. If our limit is approaching plus infinity, then this will be positive. So we are approaching in this case from plus side, correct? So let me just sketch our coordinate system and then show you what I'm trying to say. So when we are approaching from plus infinity, then this 2 over 2x minus 3 is going to be positive, right? It may be 0, very, very close to 0, I mean, but we are approaching in this fashion. And that is the horizontal asymptote. This is the horizontal asymptote. Now let's consider the second case. That is when we do all this calculation, but this time when x approaches with minus infinity, right? So we'll change this to x approaches minus infinity, right? Everything else remains same, minus infinity. So this becomes x approaches minus infinity. Now minus infinity means minus large number, right? Like you can put 10,000 minus. So if I put minus 10,000 and use calculator, I'll get definitely a negative value. So it may be 0.0000 whatever, but it will be negative. So we are approaching from the negative side. So the graph will be approaching like this, the x-axis. So that is kind of very important to figure out when we are sketching graphs, right? So that is called behavior near the horizontal asymptote, correct? Well, the question was just to figure out what is the equation of horizontal asymptote. Equation will always be y equals to 0 in this case. But this is in addition to that. If you are interested in exactly knowing how the function is approaching, then that is one thing which you should be looking into. So we say when this function approaches from positive infinity, right? X approaches positive infinity, then you approach, y is approaching 0 plus, right? 0 plus. But in case of negative, it is approaching 0 from the negative side. So that is another way of writing the same thing. I hope the concept is clear to you. We'll cover this part when we do curve sketching. Thank you and all the best.